If you've built an analytics platform on Azure, you've probably stitched together Data Factory, a Synapse workspace, an Azure Data Lake storage account, and Power BI, then spent weeks wiring identities, networking, and data copies between them. Microsoft Fabric is a software as a service bundle that collapses those pieces into one tenant with one storage layer. In this video, we'll dissect a realistic Fabric analytics architecture end-to-end, where data lands, how it moves through a lakehouse, which engines query it, and the trade-offs you're accepting when you adopt it. Here's the design wheel trace. Source systems push data through Data Factory pipelines into a lakehouse that sits on OneLake. From there, two query engines read the same files: a Spark runtime for transformation and a serverless SQL endpoint for queries. Power BI reports sit on top using DirectLake. Everything lives inside one Fabric capacity, built as compute units and one tenant-wide OneLake. The key architectural decision is that storage is shared and open, while compute engines are swappable. Keep that separation in mind as we go layer by layer. OneLake is the foundation, and it's the most important concept. Think of it as one data lake storage Gen 2 account automatically provisioned for your entire tenant, with no storage accounts to manage. Every Fabric item gets a folder, and all tabular data is stored as Delta Parquet files. The big feature is shortcuts, pointers to data in Amazon S3, Google Cloud Storage, or another lakehouse, so you query data in place without copying it. The promise is one copy of data, open format, accessible by any engine that speaks Delta. The lakehouse is where raw files become query-ready tables. The common pattern is Medallion architecture: a bronze layer of raw ingested data, a silver layer that's cleaned and conformed, and a gold layer of business-ready aggregates. Data Factory or Spark notebooks move data between these layers, writing Delta tables at each stage. A lakehouse exposes two interfaces over the same files: a files area for unstructured data and a tables area registered in the metastore. That dual nature is why a lakehouse can serve both data scientists and SQL analysts from one store. Fabric gives you two compute experiences over the same OneLake data, and choosing between them trips people up. A lakehouse is Spark first. You write notebooks in Python or Scala, and you get a read-only SQL endpoint for queries. A warehouse is a full transactional SQL engine with multi-table writes and T-SQL DML. Rule of thumb: pick the lakehouse when your team lives in Spark and data engineering. Pick the warehouse when you need SQL native transactions and a familiar T-SQL surface. Both write Delta to the same lake, so the boundary is about who's driving, not where data sits. Here's where the unified storage pays off. Traditionally, Power BI either imports data into an in-memory model, which means a copy and a refresh schedule, or uses DirectQuery, which is slower per query. Direct Lake mode is the third option. The semantic model reads Delta Parquet files straight from OneLake, paging columns into memory on demand. You get near import performance with no data duplication and no scheduled refresh. The catch: Direct Lake has guardrails on model size and falls back to DirectQuery when exceeded, so check the current Fabric docs for the limits tied to your capacity. Now the honest part. Fabric capacity is a shared pool of compute units, so a runaway Spark job can throttle Power BI reports through capacity smoothing and throttling. Plan capacity and isolate workloads. Because storage is SaaS managed, you give up some control over networking and lifecycle policies you'd have with your own data lake account, though private link and managed networking are maturing. Vendor lock-in is real on the orchestration and metastore layer, even if Delta files stay open. And pricing is capacity-based, not pure consumption, so idle capacity still bills. Model your usage before committing. To recap the architecture, OneLake is one open Delta store for the tenant. The lakehouse and warehouse are swappable compute engines over that store, and DirectLake lets Power BI read it with no copies. The whole thing runs on a shared capacity you must size and govern. Here's your concrete next step. Spin up a trial capacity, create one lakehouse, and use a shortcut to point at existing data in your current lake instead of copying it. That single experiment shows you the in-place model that makes Fabric different. And always verify capacity limits and pricing in the current Azure docs before you design for production. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.